Can you hear me? Can you hear me, Sapna Vijay?
Yes, ma'am.
Thank you. Next heading is equations of first order gaseous phase. It's only 8:28. Let's wait. Equation for first order in gaseous phase. Next heading. Equations for first order. First order gaseous phase. Equations for first order gaseous phase. Gas means the first and foremost word that comes to your mind is what? Gas. Answer? Yes.
Can flow easily.
What gas means?
Ma'am, can flow easily.
What?
Ma'am, it can flow easily.
In class 12th, the word that should come to your mind is gas. Who will say? Gas. For us, gas means, how can the concentration of a gas can be expressed in terms of
Pressure.
pressure? Gas means for us, first and foremost thing, that is pressure. Don't say gas, instead you can say pressure. Okay, for us it is pressure. Of course, it can flow to some that is for class 9 and all. For us, the main thing, the main word for gas is pressure. 11th onwards, gas means pressure. You can replace that word gas by pressure. Okay, so gaseous phase, equation for first order. What is first order equation? Is equal to 2.03 upon K, or K is equal to 2.303 upon T, log R naught, that is the initial concentration, upon R, that is the remaining concentration. All right. You can write K here, K, then T here. K is equal to 2.303. Till this time we were talking about T is equal to T is equal to T is equal to, because we had to come to T half. T and T half. Now I am doing with K, or you can do with T, because here we are calculating mainly K. Once you get K, you can write the rate of the reaction. Rate is equal to K into A to the power, here it is 1. K into A to the power 1. Anyway, it should be 1. Even if some other reactant is there, it cannot be 1. It could be 0 only, because it is equation for first order. Overall order should be 1. So minimum A to the power 1. All right. So we are going to see the K of this equations for first order gaseous phase. So reactant is a gas, reactants are gases, products are also gases. In such condition, we are going for first order. Yes, I am taking gas in the cylinder. Suppose I have taken A, this gas A in this. Suppose this A is undergoing decomposition. A is undergoing decomposition. Decomposition will form products, for example, B and C. Products B and C. Now see that B and C are produced inside this thing only. If there is remaining A, that is also present in this thing only. So after the reaction, what I am going to write there is, what I am going to write there, I am not drawing, instead I am showing you this only. Now it is B, C and unreacted A, that means remaining A. Remaining A, unreacted A means remaining A. All the three things are present in this. B, product, C, product, and the remaining A. Now the pressure is due to these three gases. All are gaseous products. These three gases, previously, before starting the reaction, the pressure is due to only due to A. The pressure is only due to A. That is the initial pressure. In that equation, you see that equation A is equal to 2.303 upon T. No, R0 upon R. Concentration of the gas, that is pressure, P naught. Concentration of that remaining reactant, that is remaining A, that is write it as Pi, and that remaining, that is P. All right. Initially, you can write P naught, no problem, or Pi. In some cases, they print as Pi or P naught. So both you should know. Pi means P initial, and P, that is remaining pressure. Now again, I am going back situation. Only A was there. Only A. Reaction not yet started. You can measure the concentration in terms of pressure by using a manometer. You can measure its pressure, that is PI, P initial. PI initial pressure of the reactant A. Alright? You can measure initial pressure, and once the reaction done, at any moment you can find the second measurement, that is P total. Why P total? B is there, C is there, remaining A. Remaining A is also there. This is P total. So first we measured only of A, that is PI. Now after a time T, now what we are measuring is P total. P total. So only two measurements you can do from this in terms of pressure. Time you can find out, determine time you can find out using a stopwatch. When the reaction starts, you switch on the stopwatch. Alright. So two pressure measurements you can do. One is PI and one is P total. But we don't want P total. We want this remaining case pressure. We don't want P total. But using P total, you can find out. Using P total and PI, you can find out the speed. How can we do that? That is the main thing of this topic. How to find out that. Alright? So for that, we are going for balanced improvement. That is A gives B plus C. All are the reactions. First, you have to balance this equation. It is the general format. Okay. What was the initial concentration in terms of pressure? That is PI. PI. After a time T, now it is P. Now it is P total, but here PI nahi for A. If I write only for A, the pressure of A, that is reduced. Pressure कुछ कम हो गया. How much gone? We don't know. Let it be X. This is the remaining pressure of A. Right? This is the remaining pressure of A. Now, X gone. That side from A, from the reactant A, X gone that side. When one goes, one B is produced, one A is produced. When X goes, A is produced, X B is produced. Total pressure is PT. This is equal to PT. This is the total pressure. What we measured after a time T, that is PT. Alright? So, this was things we come to know. Once again, initially, at the starting of this reaction, only A was there. Let its pressure is PI, yeah, P naught. And after a time T, that PI is not there for A. From PI, something is less. What is less? The less is X. How much is less? X is less. Okay? X gone. X lost. X gone that side. When one A goes that side, one B and one C are produced. When X goes that side, XB and XC Xc. So X B are there. Pressure of B, mu B is X. Pressure of form C, that is X. 1 X X. So adding, so in that box after a time t, in the box, this remaining A, this we require for that P, right? Remaining A, that is K is equal to 2.303 upon T. Log P naught, you can measure, that is Pi, and P, what is P? Remaining A, that is Pi minus X. And write that equation again, K is equal to 2.303 upon T log Pi upon Pi minus X. That P means Pi minus X. Pi minus X will be the value of X. What is the value of X? See, this we know, this relation we know. Pi minus X plus X plus X. So minus X plus X got cancelled. Pi plus X is equal to Pt, or X is equal to Pt minus Pi. X is equal to Pt minus Pi. Pt we can measure, Pi we can measure. So X value is okay, that is Pt minus Pi. Pt minus Pi. Now you see, everything is in our hands. Pi we can measure, Pi we can measure, Pt we can measure, Pi we can measure. Right? So this will be minus Pt plus Pi. That means 2Pi minus Pt. 2Pi minus Pt. Alright. So here Pi we can measure, Pt we can measure. So only two things we can measure, and one more, that is time wise, how much we can do. We can find out K. Once you get K, you can write the rate law. Once you get K, you can write the rate law. That is, rate is equal to K into calculated K into A to the power 1. Another example. Alright, before doing the next example, do this question. The following data were obtained. The following data were obtained. The following data were obtained during the first order thermal decomposition of SO2 gas gives SO2 gas plus CO2 plus CO2. Conceive SO2 gas gives SO2 gas plus the table is given. Serial number, time, total pressure. We started zero time, total pressure is in atmosphere. Initial pressure 0.5, 0.5 atmosphere. Initial pressure 0.5 atmosphere. Serial number 2. 100 seconds. We started. When it covered 100 seconds, the total pressure is 0.6. This is PT. The total pressure is given below. This is given in the form of total pressure, of course, correct? At zero timing, the pressure is the total pressure actually goes initial. Actually, this is PI, this is PI, and this is PT. Right? You can calculate the question. Calculate the rate of reaction. Calculate the rate of reaction. For finding out the rate of rate low, rate is equal to rate constant into a to the power 1. That is SO2Cl2 to the power 1. So what is the rate of this equation? Rate of this equation is equal to rate constant. Rate is equal to rate constant into SO2 to the power 1. SO2Cl2 to the power 1. SO2Cl2 at a particular time, what is the remaining concentration of that SO2Cl2? That is to be put inside that rate group. Alright, so calculate the rate of reaction when total pressure is calculate the rate of reaction. Rate means rate is equal to rate constant into SO2Cl2 to the power 1. Once again, calculate the rate of reaction when the total pressure is 0.5 atmosphere. 0.65 atmosphere. You have to calculate the rate of reaction at this particular time when the total pressure is 0.65 atmosphere. Okay. So we have to calculate the rate of reaction. Rate of reaction, first you find out the rate of reaction. Then we will go for rate of reaction. To find the rate of reaction, that K is required. Rate is equal to this is the rate of reaction. Rate is equal to K into SO2Cl2 to the power 1. Means, and K you can find out. Just now we have found out K. PT and PL. SO2Cl2 is concentration. What is the concentration of SO2Cl2 when the total pressure is 0.65? That is the question. You have to write the rate of the reaction. Rate of the reaction is equal to, for finding rate of the reaction, you have to find out two things you need. That is K. K for this reaction. K is constant for the reaction. K you have to find. And the concentration of SO2Cl2 when the total pressure is 0.65. Alright. K is a constant for a reaction. K will change when the temperature will change, but that is taken out from your syllabus. Last year that was there. With temperature, how the K changes with Arrhenius equation. So let's find out K first. Find out K. What is this equation given? That is SO2Cl2. One SO2Cl2 when it decomposes, one SO2 and Cl2 will be coming. Okay, one SO2Cl2 when it decomposes, one gives one and one, just like A gave B plus C. So in that way, we are calculating here also. That is K is equal to 0.303 upon. This equation is similar to that A gives B plus C. So 2.03 upon G log Pi upon Pi minus X. Right? Pi minus X, that means 2Pi minus Pt. 2Pi minus Pt. I am taking 2Pi minus Pt because this equation is similar to the previous what I explained. 100 seconds. Pi, what is Pi? 0.5. What is 2Pi? 2Pi minus Pt. 2Pi, that is 1. Right? 0.5 into 2. 0.5 into 2, that is 1. Minus Pt, 0.6. So that will be 0.4. So I am writing it as 2Pi into this 0.5 into 2, that is 1. Minus Pt, 1 minus 0.6, that is 0.4. I have written here 0.5. 0.5 upon 0.5. So you can calculate this. After calculation, I am giving you K value, that is 2.2 into 10 to the power minus 3. 2.2 into 10 to the power minus 3 second inverse. Okay? 2.2 into 10 to the power minus 3 second inverse. K is obtained. Now what do you have to find out? Rate is equal to, rate you have to find out, that is K into K, that is 2.2 into 10 to the power minus 3 second inverse into SO2 concentration at point SO2 concentration when the total pressure is 0.65. When the total pressure is 0.65. All right. So for that, you write that equation ahead. SO2 gas is SO2 gas plus Cl2 gas. The same thing we are applying for when Pt is equal to 0.65. Alright? So initially 0.5. That is equal to 0. After the time, after a particular time, so 0.05, here it is 0, 0, and the reaction started. Now, afterwards, it is only 0.5 minus x. Just like the previous one, x gone. So here x and x form, and the total pressure is 0.65. Total pressure is 0.65. 0.65. So here you add, that is 0.5 minus x plus x is equal to 0.65. This got cancelled, so 0.5 plus x is equal to 0.65, or x is equal to 0.65 minus 0.5. This is the remaining concentration. That is remaining concentration, that is 0.5 minus x. So for that we are finding out x. That is equal to 0.15. 0.1. So x we have what? Now you can put in that rate equation, that is rate is equal to rate constant. What is the rate constant? 2.2 into 10 to the power minus 3 second inverse into what is the remaining concentration? That is 0.5 minus x. X we have already found that is 0.5. 0.5 minus x. This we have to substitute. Right? 0.5 minus 0.15. Alright? This much atmosphere. This much atmosphere. This much atmosphere. So you calculate and tell me the answer. What's the answer?
7.7
7.7
4.
Into 10 to the power
minus 4.
atmosphere second inverse. Okay, thank you. Next equation you write, that is another example. 2N2O5 gives 2N2O5 gives 2N2O4 plus O2. 2N2O4 plus O2. Now one pseudo first order reaction is remaining, that will take only 5 to 10 minutes. Then next chapter, solid state, I will start on Tuesday. Monday, no class for you. So on Tuesday. Thank you all of you.